Hello and welcome to the technical presentation of MusICE. MusICE is a simple service which allows automatic switching of air conditioning devices without needing a wireless connection between the main hub and the activators. It is a microservice-based architecture. The main microservice is the Home Catalog. As the main service, it exposes two APIs, the REST API to receive instructions from the user on how the application should work, and an MQTT API, which establishes a two-way communication with the actual actuators. There are two types of settings in the system. Device settings, which can be toggled in real time while the application is running, and they express the user decisions on how the system should work. And strategy settings, which are available to developers to easily develop new strategies. To create a new strategy, all it's needed is to create a Python file containing a microservice with the code for the strategy, and then to update the strategy.json file with information regarding which parameters are needed by the strategy. Using this file, the graphical user interface provides the user with an interface which allows configuration of every strategy automatically. The user, in addition to the app or graphical user interface, can also use Telegram, and a translator translates the user commands into REST API commands to be executed by the Home Catalog. Using device settings and strategy settings, the Home Catalog can send a specifically tailored request to the strategies. Each strategy is a completely stateless service exposing a REST API. It is given as input the relative settings as set by the user and the measurements given by the client. In return, it has to give a Boolean value, whether the system should be on or off. Aggregating the response from the strategies, a single Boolean is taken as a result, true or false, for every device. This is sent to the message broker and then to the PyTranslator, which acts as a simple client in the MQTT service, but actually provides transparent translation from MQTT to music. How the music works is very simple. It uses sine waves to communicate 8 possible symbols. Therefore, every note represents 3 bits in the message. On the other side, the client listens using a microphone and can reconstruct the original message. Clients go through an authentication process, which will be described further. As previously said, the sine waves in the melody represents 3 beats at each time. The chords are just for aesthetic purpose, and they do not serve anything in the process of communication. As you can see, the client sends a pair request on the service topic. The pair request is followed by its serial number, which is kept short for the purpose of the video. The Home Catalog responds with a pairak to signify that it has received the request and it has accepted it. The pair is followed by the serial number of the device and the connection code. Connection code is supposed to be a short code which allows more efficient communication between the client and the home catalog. Every 5 minutes, the temperature is sent by the client to the home catalog using the connection code that it was previously assigned to. We can clearly see that the temperature is followed by an active by the home catalog. The active is in response to the temperature and it signifies the decision of the strategies as to whether the device should be turned on or turned off. You can see in this case, the device was turned off. In the strategies.json, every strategy has three simple fields. Its name, which is something which allows the user to know what the strategy does, the port on which it is reachable on localhost, and the settings array. The settings array contains a list of all the variables the strategy needs to function. It contains a name, a type, and if it's a number, the minimum and maximum value. The graphical user interface will take all these settings and turn them into a graphical card which the user can use to set up the strategy. When the device connects, it will appear here in the dashboard. The device will have its serial number, an automatically generated name if it didn't have one assigned by the user before, a toggle to turn it manually off, on, or in automatic mode, and a dedicated panel. The name of the device can be easily changed. When in automatic mode, the device will use the strategies to determine whether it's on and off. You can go into the home panel here to see a graphic of the temperature every 5 minutes for this device, and then the strategy selection menu, which allows you to activate the strategies indicated in strategies.json and configure them. Timer control has of course a time selection, which means turn on and turn off, and can be configured using this visual clock. Temperature control has two number inputs, which can be configured using the sliders.